Okay, so having said that, let's go to some examples, right? So let's see this function 3x squared plus x plus 1 divided by x plus 2. Okay, so let's start with the first one. What's the domain? Well, the domain of f is, we have a rational function, right? And we know that rational functions, their domain is R minus the points that make the denominator be 0. In this case, it's minus 2. Okay, so it's the only point where the function is not going to be defined, and we're going to see that there's a vertical asymptote there, right? We can't see any obvious symmetries, right? It's not even, it's not odd, it's not periodic, and it's always going to be, obviously going to be continuous and differentiable everywhere except in the point where it's not defined, so that's fine. So in the domain, right? So let's find, so yeah, that's 2 and 3. Let's find the zeros first. Okay, the zeros are the points that make 3x squared plus x plus 1 equals 0, right? And so yeah, this is actually positive, right? This is 1 minus 12, so it no real roots, okay? No real solutions. There are no points in which f crosses the x-axis, so no zeros. Okay, this is a parabola that doesn't touch the x-axis. Now about growth, let's compute the first derivative. The first derivative is going to be x plus 2 squared, and then we have the derivative of this, which is 6x plus 1 times x plus 2 minus, and then we have 3x squared plus x plus 1, right? And if we expand this, we have 6x squared plus 13x, right? Plus 2 minus 3x squared minus x minus 1 divided by x plus 2 squared, or in other words, this is 3x plus 12x plus 1 divided by x plus 2 squared. Now let's see, the derivative is 0 whenever 3x plus 12x, sorry, 3x squared plus 12x plus 1 is 0. Okay, and we can find the root of this. This is x minus 12 plus minus 144 minus 12. Okay, and then we have 6, right? So this is equal to minus 2 plus minus, and then we can get this divided. So this is 144 minus 12 is 132. Which is a multiple of 3, it's a multiple of 6, right? So this is 6 as 22, right? So this is 22 times 6, right? So this is 22 times 6 divided by 6 squared, 36. Okay, so this is 22 divided by 6, in other words, 11 divided by 3. Okay, so this is the square root of 11 divided by 3, and if you compute this numerically, this is approximately equal to the negative one is going to be minus 3.91, and the positive one is going to be minus 0.0, so very close to 0, right? Let me go back here. Okay, now let's see. So the derivative is going to be, this is a parabola, it's positive parabola, right? So this is going to be positive, f prime is going to be positive if x is smaller than x1 and x is greater than x2, right? And is going to be negative if x is between x1 and x2, right? So we have, let's say, this is increasing up until you get to x, so that this is a maximum, okay? Maximum, and then it's, let's say, this is decreasing up until you get to this, and then after that it increases, so this is a minimum, okay? and then we can compute, let's see, we have a minimum, no zeros, and yeah, we don't really need to analyze the concavity, because we're going to see it now. We just need to compute what happens at the asymptote, right? So there's the limit when x goes to -2 on the left of f, and this is going to be, let's see, what's the x, well, let me erase this, wait a minute, let's compute the value of the asymptote. So this is it. The limit when x goes to -2 on the left of f is going to be, let's see, this is going to be, it's 12 minus 2, 10 plus 1, so this is positive, so this is going to be negative, right? So positive divided by, this is going to be negative, approaching 0, so this is going to be minus infinity. The limit when you approach 0 on the right, this is positive and this is positive, so this is plus infinity. Okay, so now let me go back here and try to plot this thing. Oh yes, so yeah, and what happens with the limit when x goes to plus minus infinity of f. Again, and this function is 3x squared plus x plus 1. So that's the limit when x 3x squared plus x plus 1 divided by x plus 2, and we see that this is going to be the limit of 3x when x goes to plus minus infinity, so it's going to be plus infinity when it goes to plus infinity and minus infinity when it goes to minus infinity. Okay, so let's see. An interesting thing is that we can't really find horizontal asymptote, but can we find a vertical asymptote, right? So this is, sorry, an inclined asymptote. Okay, so if we have the limit when x goes to, and then plus minus infinity of 3x squared plus x plus 1 divided by x squared plus 2x, this limit is going to be 3 in both cases, so we have it's going to be an inclined asymptote, right? This is going to increase, but just as fast as 3x, right? And now that we have to find a limit when x goes to plus minus infinity of f minus 3x, and then in this case what we have is the limit when x goes to plus minus infinity of 3x squared plus x plus 1 minus 3x squared minus 6x divided by x plus 2, right? And so this and this go away, so we have minus 5, sorry, the limit when x goes to plus minus infinity of minus 5x plus 1 divided by x plus 2, and this is going to be minus 5 independently on the of the sign, so we have an inclined asymptote that it's the same in both cases, right? So now we have that. This is an inclined asymptote. Let me see if I can plot this thing. Okay, so let's see. We have that there's a vertical asymptote at -2, right? So we have this. Oops, sorry. Okay, -2. We know that the limit when you go to -2 from the right is plus infinity, minus infinity here. There's a 0, and there's no 0, right? But close to 0 you have a minimum, and the value of that function, and so remember that f is 3x squared plus x plus 1 divided by x plus 2, and very close to 0 this is just 1 divided by 2, so almost half. Okay, very close to a half. So let's see, it's a minimum here, for instance, right? And then we have a maximum here at -4, for instance, close to -4. So this is 16 times 3 is 48, minus 4 is 44, plus 1, 45, divided by minus 2, so it's minus whatever, right? So some point here, and this is minus 3, minus 4, point here. And then we have this line, 3x minus 5, and wait, let me just plot it like this. Okay, this is the asymptote. Okay, then 4, we have this value, and so we know that the function is going to be very close to this until it gets to the maximum, and then it starts increasing, right? So you can see that you can see that the concavity, so this is a function that's it's going to be, right, it's going to be concave in the negative, sorry, left of the asymptote, and then it's going to be convex in the, okay, convex on the left of the asymptote, right? So and this is the function 3x minus 5, right? So this is what the function looks like, more or less. Okay.